Hello, my name is John Ben, and we're just going to go through a practice physics question on waves. This is to do with wavelength, frequency, wave speed, and also looking maybe a little bit of understanding about antiphase, phase and antiphase. And what an interesting question this is. So in our course textbook, it's page 217. It's question 3A. So we're just going to have a look at this. Now, the question says we've got two fishing floats, a distance of 4.5 meters apart. So we're going to draw some floats, and they're 4.5 meters apart. Okay, and the floats are bobbing up and down. Okay, 20 times a minute. So we'll come back to that. So 20 bobs, 20 oscillations in 60 seconds. We'll come back to that in a minute. All right, what else does it tell us? The floats move in antiphase. So what that means is that when one float is at the top of a wave, a crest of a wave, and the other float that's 4.5 meters away is at the trough, is at a trough. That's what we mean by antiphase. So as this one goes down now, this one goes up. Does the opposite things. We could say 180 degrees out of phase, or even pi radians out of phase. Okay, so what else do we know? It says that there's at least one crest between the two of them. So there's going to be another crest in there. But there's never, but not two or more. All right, so that tells us something. So if there was no crests, they'd just look like that. You'd have no crests in between. That's not what's going on. But it says we've got one. So how could we draw that? So this goes up to a crest. It does mean we're going to have another trough in there, because we've got to have a crest between those two, and that comes up to the rest of that wave. Okay, so that gives us a bit of a better idea. So that's 4.5 meters across, and this is one crest, then down, and then back to the next crest. So that distance there is the shortest distance between two adjacent points. So that's one wavelength. I'll use the symbol lambda as usual. And then where's this one? Well, this is in antiphase. So this is the point is at the top. This point's at the bottom, and that's actually half a wavelength. So what that tells us is that 1.5 wavelengths is the same as 4.5. Okay, we can rearrange that to work out what lambda is in meters. I'm not going to do it. I'm going to let people do that. Hopefully that is going to come up with an answer that matches what's in the question. And then it says, hence find the speed of the ripples on the surface of the wave. So now we know that what the wavelength is. And we need to work out the wave speed. We need to use our wave equation, v equals f lambda. Don't need the diagram now, really. Okay, v equals f lambda. And so we've worked out the wavelength. We're going to work out this thing, so we need to know the frequency, and this is where our information from the question is going to help us. So frequency is the time for one complete oscillation. We've got 20 of those. So it's not. It's the frequency is the number of oscillations in 1 second per unit time. 1 second. Okay, and so therefore, if we've got 20 oscillations in 60 seconds, how many oscillations are we going to have in 1 second? We just divide the 20 by the 60 seconds, and that will tell us how many oscillations in 1 second. Once we've got that, we've now got the wavelength, we've now got the frequency, we multiply them together, and we get an answer for the wave speed. Hope that gives you a few hints on how to go about that question. All right, best of luck. Thanks for asking as well. Best of luck with the rest.